So, last class I have shown that how I will get the net pressure diagram from the sheet pile which is installed in cohesive soil, and there are 4 zones and like the cohesionless soil, and then we got the net pressure distribution diagram. Now, today I will show you that from that net pressure distribution diagram how I will got the d value expression. Okay. So, this was the expression that we got in the last class. Okay. Now, from this expression, so I will get the expression of from this diagram I will get the expression of d. So, this is I am taking the summation of all horizontal forces 0. So, what are the forces are coming? So, what I am doing again here also I am taking this construction line I am drawing. So, what I am doing that I am taking the horizontal forces. So, one horizontal force will act is this P A. Okay. Another forces are, this is the force P due to this triangle. If I say this is this triangle, okay, this is the triangle, and here this is the P, this is P rectangle. Okay. So, I am getting that forces means P A plus P due to this triangle, okay, minus P due to this rectangle, that will be 0. So, what I am doing I am considering this triangle, okay, and then I am taking this rectangle also, and both are opposite sides. So, this portion I have taken twice, this dotted portion I have taken twice, one I have added, and in the triangle I have added this portion, and in the rectangle I have also added that portion. So, and both the forces are acting in opposite direction. So, this portion is automatically cancelled. Okay. So, that is why I have taken these two portion, but forces are in both the opposite direction. So, this portion will automatically cancel. So, now the P A, as I mentioned, P A is the only positive part that you have to consider. Now, the P A plus this triangle portion, if I say this is the z value, z value is the height of this triangle. Okay. From this point, this is z. So, I can write that half into z height plus the base. Base is, this is 4 cu plus q bar, this one 4 cu minus q bar. So, I can write 4 cu plus q bar plus 4 cu minus q bar. Okay. This is for the triangle. Then the rectangle, it is a rectangle and this side is 4 cu minus q bar. So, I can write this is d 4 cu minus q bar, that is equal to 0. So, finally, if I further simplify this thing, this is P A plus half z 8 cu, okay, 8 cu minus d 4 cu minus q bar. So, this is 0. So, z value I will get from this expression is d 4 cu minus q bar minus P A, and this will be the 4 cu. Okay. So, this is equation number 1. Similarly, I will take this is the B point, summation of all moment taking from B point is 0. So, again there is 3 forces. So, I am writing that this is P A, the lever arm will be the capital this lever arm, that will be your d plus y bar. So, this is the total is d. So, this will be d plus y bar is the lever arm, because from this point this is the d plus y bar, and then plus this portion your triangle, because of this triangular force, this is half into z into 4 cu plus q bar plus 4 cu minus q bar, then into it will act as a height of z by 3, then minus will be that this is the rectangle which is d 4 cu minus q bar into this will be d by 2, that is equal to 0. Okay. So, if I finally simplify this expression, I can write d square 4 cu minus q bar minus 2 d pa minus pa 12 cu y bar plus Pa divided by 2 Cu plus Q bar is equal to 0. I have replaced this Z value with this expression. Okay. So, Z is replaced by this expression 1. So, this Z is replaced with this expression. Okay. So, finally, I will get this equation, and where remember that where Q bar is equal to gamma H or gamma bar H depending upon the position of the water table. Okay. So, and you solve this D from this equation, then you increase it, find D from equation 2 and increase it by 22, 30 or 40%. Okay. So, this is the equation to determine the depth of a cantilever sheet pile in cohesive soil. Okay. So, and the solution process is same that the problem I have solved for the granular soil case, because here you have to use these two expression, and Pa you will get from this triangle, and but remember that there may be some C5 soil also in this top portion. So, depending upon your soil you will get a earth pressure distribution diagram. So, you take the positive part of that diagram only and get the Pa value and calculate the y bar, that I have also shown how to calculate the y bar, and then you will get this z expression, put those values. Now, that z expression you put here, you will get this total expression. So, this q bar you determine depending upon if is the total soil is below the water table, then you have to consider gamma sub into H, but some portion of the soil may be above the water table, some portion may be below the water table. So, above the water table you have to consider gamma into H, and below the water table you have to consider gamma dash or gamma sub into that H1 or H2, whatever the height. Okay. So, remember that Q you have to consider depending upon the water table. If it is some portion of the soil is above water table, consider the gamma. If some portion of the soil is below water table, consider the gamma dash or gamma sub. Okay. And I have solved a similar problem in the granular soil case. So, the next part that I will start is the your anchor sheet pile. Okay. And I will consider the anchor sheet pile both for C and phi soil. So, this is the anchor sheet pile. Okay. So, this anchor sheet pile, so as I have shown, instead of in the cantilever sheet pile, this is the dredge level and this is the ground level. Okay. So, here we are putting anchorage and apply some tension. Okay. So, that means this is the anchorage, a rod where a plate can be attached, which will be inserted into the soil. So, that will give an anchorage. So, what is the advantage? Here a force F is acting, that means F force you are applying on the sheet pile. So, that automatically you are giving some resistance F in the sheet pile. The advantage of these things that it will reduce the required depth of the sheet pile, and if your height of H is very large, then also you can provide the anchorage. So, then you can reduce the depth of the sheet pile. Okay. So, here your deformation shape is considered as, if it is so this is the two methods generally we consider. So, one is free earth method, another is fixed earth method. So, in this course I will only concentrate in the free earth method. Okay. I will discuss only the free earth method, fixed earth method I will not discuss in this course. Okay. So, first the distribution that I am talking about, this is the free earth method that as I mentioned I will discuss only the free earth method. So, we have two cases, one is in the granular soil, or is in the sea soil. So, first I will discuss about the granular soil part, then I will discuss about the cohesive soil part. Okay. So, in the free earth method, it is, say, assume that your wall is rotating like this. Okay. This is the wall representation. It is free earth means this base is free, it is not fixed. Fixed means it will be fixed. So, suppose if your depth of the sheet pile is relatively less, then you can consider the free earth method, but if it is very high, then the lower portion will also be will not rotate. So, that is the fixed condition. So, that we will not discuss here. I will discuss the free earth method where your base is rotating. So, and it is rotating about the anchor rod position. Okay. So, and so that means here also you have this is the this portion is active, this portion is passive, but there is a small portion above the anchor rod. So, this is the anchor position, above the anchor position there is a small portion where you can say this portion is passive, but as it is a very small portion. So, that is why you are neglecting that condition, and we are assuming that this right side is total active and this left side is total passive. So, this is our active and this is the passive condition. Okay. So, if it is a granular soil, then as it is total active and passive condition. So, this portion is passive, this portion is active. So, if we can draw that this is my earth pressure distribution, this is the active condition. Now, from here up to this is only active. Now, below the dredge level, this side is active, this side is passive, left side is active, right side is passive, and definitely your passive force will be greater than the active force. So, what will happen? Your diagram will shift from right side to left side. Okay. So, this will be the diagram of this case. Okay. And there will be a force F. Fine, this is the anchorage force. So, this is the earth pressure distribution diagram. So, I can write this is P A, okay, and this is the E. So, this is I can write P A E, this is the A point, this is the B point or O point at which the net earth pressure is 0. So, this is the net earth pressure diagram. Okay. So, you can draw again the separately the active and passive pressure diagram. So, this is the total active and this side will be total passive. Okay. So, passive will be here. But in the cantilever sheet pile case, it was active passive 4 zones, but here only the right side is total active and left side is total passive. So, up to here the net earth pressure diagram, this will be the active, then it will shift from this side to other side, okay, because at the passive is more. So, it will shift. Okay. Now, quickly I will give you that how I will determine this values. This is the D and these values say capital Y and this one is A or A dash, because in case of previous problem I consider this is A dash. Okay. And this is the force which is acting P A. So, what I will do, I will consider this P A considering this above the O point, and then there is a force say P P, okay, because of this triangle. So, I can write that the F force is the anchor force and your unit weight is gamma or gamma dash depending upon the water table condition. So, the summation of all horizontal forces is 0. So, F H is 0. So, what are the horizontal forces? The horizontal forces are F, this is the anchor force, plus P P plus P P minus P A, that is equal to 0. Okay. And now, from the the A dash value I will get from the previous granular soil, the cantilever sheet pile in granular soil, I get that this is P A E divided by gamma or gamma dash into K P minus K A. Okay. So, that is the A dash I will get. Then next one, that I will take the moment at rod level. Okay. So, I will take a moment with this point. Okay. At rod level it is 0. So, I am taking the value that this is the P A and Y dash, and I am taking that P A is at a distance of Y 1 bar, and this one is, this is say H, small h, this one capital H, and this height is say capital H minus small h, and from here to the P P is Y 2 bar. Okay. So, the lever arm of P A is Y 1 bar from the F, that will be equal to the P P, and lever arm is Y 2 bar. Okay. And P P value I can write that you know here net earth pressure is 0. Okay. At O point net earth pressure is 0, then it will increase this value. Okay. So, the net earth pressure, this P P or this value will be K P minus K A into capital Y. So, that this is the same thing I did in the last problem of cantilever sheet pile in granular soil. So, this value is K P minus K A into Y, because this is net earth pressure into Y, Y is the capital Y. So, I can write that P P is, P P will be half, and this will be the gamma also. Okay. This is gamma into K P minus K A into capital Y. So, this will be the half gamma K P minus K A, this is this due to this triangle, this is the base into Y. Okay. This is the your Kp into another y, because this is the base is gamma Kp minus Ka into y, then into another y, this will be the Pp. So, Pp value is half into gamma into Kp minus Ka into capital Y square. Okay. And y2 bar is equal to, y2 bar will be small h, this is small h plus a dash plus 2/3 of y, because this is from base it is 1/3 of y and this is the triangle. So, this will be 2/3 of capital Y. Okay. So, finally, if I write this expression, then I will get that P A into y 1 bar, that will be equal to half, that will be equal to half gamma K P minus K A into capital Y square into h plus a dash plus 2/3 of capital Y. Okay. So, after simplifying, I will get capital Y cube gamma K P minus K A divided by 3 plus capital Y square gamma K P minus K A divided by 2 into h small h plus a dash minus P A y 1 bar is equal to 0. So, you have this final expression. Now, from this expression you find d, then increase it by 20 to 40%. Okay? You increase it. So, this is the total solution. Now, in this case we have an anchor also. So, how to design this anchor? So, that is also important. Okay? So, I will solve that first. I will discuss that how we will design this anchor, because here that you have an anchor and then from that solution. So, if you look at this solution, that from this solution you will get capital Y. Now, your d value is capital Y plus a dash you will get from this expression. You have the capital Y, so you will get the d and you know the h. So, your total h plus d you know. Okay. Now, once you get the d, now you put this capital Y, you that put you capital Y here, you will get the Pp, Pa you will get from this diagram. Remember that this diagram from Pp value you will get the values from O to A, this total one is Pp or Pa. Okay. So, Pa is the distribution, the force due to this portion of this diagram from O to A, and once you get the Pa Pp, then you will get the F value. So, from this expression F will be equal to your Pa minus Pp. Okay. So, that will give you the F value, final F value. So, that F value, once you get this F value, now I have to design the anchor. So, now if this is the retaining or the sheet pile wall. So, now I know the d value and the h value is known. So, this is the d value. Okay. Now, the sheet pile, it assume that there will be a line. So, this is the ground surface GL. Okay. So, I will draw a line which is 45 degree plus phi by 2, because this is the active side. So, this may be the this will be the failure zone or failure surface. So, you cannot put the anchor in this zone. So, and then you draw a 90 degree line here. Okay. This is 90 degree. So, your anchor that you will place, this is the anchor sheet that should be above this line. You cannot put anchor in this zone. This anchor should be above this line, okay, above these dotted lines. So, this is the anchor position, okay, in terms of horizontally. Now, the vertically, what would be the depth of this H is the say depth of the anchor, and B is the this width of the anchor. Okay. So, what I can say that this is the anchor. So, this is the anchor B into L. L means in the lengthwise. So, now if I draw the plan, this is the section, the plan will be maybe this is the plan. Okay. So, this is the length L and this is the thickness say T. Okay. So, this is the plan, this is the length, and so you can put anchors like these also in terms of plan. If I draw, so you can put one anchor, then this is your sheet piles which is going continuously, then you can put another anchor like this, then another anchor like this. This is sheet pile, this is the anchor, this is the anchor rod. So, this is the plan. So, there will be some spacing between the these anchor rods. Okay. And another way, this is the discontinuous one. So, another way, this is the sheet pile. So, you can give the continuous anchor. Okay. So, this is the continuous anchor and you can put the rod here. So, this is the sheet pile. Okay. So, this is the continuous case and this is the continuous case. Continuous case where your anchor plate, this is the anchor plate which is continuous, and sometimes it cannot be, it may not be the continuous also. But if so, if it is the length and it is the T. So, now if I have a anchor is at a point here. So, this is the ground surface GL. Okay. So, and you are applying a force here this direction. So, your force is applying in this direction because your anchor is attached here, it is try to rotate. So, you are applying force of this anchor. So, anchor will move in this direction. So, this portion of the soil is active condition, this portion of the soil is passive condition, because you are pulling this anchor, your anchor is getting a reaction. This is the force of the anchor force. Okay. So, that means here this side is passive and this side is active. So, if I draw the diagram, so I can draw, this is the active pressure diagram and this side, this is the passive pressure diagram. Okay. So, I will consider this portion only because this is the anchor portion. Here also I will consider the passive pressure. This is the active pressure, this is the passive pressure. So, I can take, and generally your this is the B, B is this portion is B, this is in section. Okay. So, generally your B is greater than equal to He by 2. Okay. So, now if I draw the your passive force, this is the active force and this is the passive force. Okay. And remember that I am drawing this up to this portion, because this is the anchor portion. Some you do not consider the above portion of the pressure, because that is the pressure which is acting on the anchor. So, I can write that my PA what will be the this value, and I am considering that B is equal to H E by 2. If B is equal to H E by 2, then this portion is also H E by 2, because your B is, this is B which is H E by 2, this is B which is H E by 2, and this portion is H E. So, this will be also H E by 2. So, H E by 2, and so my PA will be this portion of the diagram. So, I can take, one is rectangle, another is the triangle. Okay. So, this rectangle, this portion is definitely, it will be K A into gamma into H E by 2. Okay. And this portion is also K A gamma H E by 2. Okay, because this is from here 0 to here. So, this is all this B, this is B is nothing but H E by 2. So, this will be K into gamma into H E by 2, and this portion is from the top, this is also K H E by 2, this will be the K A gamma into H E by 2, and this is the rectangle. So, I have a rectangle and the triangle. So, I can write the PA expression is for the rectangle is gamma K A H E by 2 into H E by 2, okay, plus the triangle is half K A gamma H E by 2 into H E by 2. Okay. So, if I take and simplify this, this will be 3 by 8 K A gamma H E by H E square. Okay. Similarly, the passive will be the same, passive pressure will be the same, 3 by 8 K P gamma H E square. Okay. So, the finally, the net pressure or net force P net, which is equal to P passive minus P active. Okay. So, this will be 3 by 8 K P minus K A gamma H E square. Okay. So, this is the value, or we can write this is 2.1 by 2.67 K P minus K A gamma H E square. Fine. So, now this is the force, and that will be equal to the force that is acting on the anchor plate. So, in the anchor the force is acting. So, this force that will be kilonewton per meter. Okay. So, that force is acting here. So, now what I will do, I will take that force and into I will put a factor of safety here. So, that force, this net force will balance this F. Okay. So, what I am doing, that I am writing that for continuous case, you can write that your L is equal to S. Now, what is L and what is S? Now, first I will balance these forces, and then so I can draw it here. So, this is the anchor plate. So, where your this is the force is acting, and the P net is is equal to 1 by 2.67 Kp minus Ka into gamma into He square. Okay? That is the value into gamma He square. Now, this P net into L, that will be the total force. Okay. If this is the L, now P net is acting here. So, this is the B is vertical direction wise and this is the F, this is the plan. So, this is the F which is acting. So, I can write that this F into L, that is the total force. Similarly, the F that this is the P, this is not F, this is P net. This is P net. Okay. So, this is the P net into L. Similarly, F into S, S is the spacing between the rod. Okay. So, because your F is acting, because this is the continuous one, and so the one total S will be, because the F as I mentioned kilonewton per meter. Now, if you multiply it with the S spacing between the anchor rod, then you will get the total force that is coming on this anchor, one particular anchor, because we are, this is the F is coming kilonewton per meter. Now, if it is spacing is the S, then you have to multiply that F, the anchor force, with the S, then you will get the total force, because it is kilonewton per meter. If you multiply the S, then I will get the total force. So, that I am doing, this is F, the anchor force, this is the anchor force, you multiply the S. So, I will get the total force. Similarly, the P net that is acting here. So, P net is also acting here into the length. If I multiply with the length in the plan wise, then I will get the total force. So, this is, and then I am giving one factor of safety. Okay. This is the factor of safety on the force. So, this is factor of safety, generally I will take it is 1.5 or 1.5 to 2. Okay. So, this is the total equation, and this is for the, if it is not continuous. Now, if it is continuous, then I can write that your L is equal to S, okay, because in that case this is continuous. So, this is the continuous. So, I will write that in that case this will be the L will be the equal to the S, because now this is the, I can say in that case your L will be this one half, here also L will be this one, this will be the L if it is continuous. Okay. Now, this is the L if it is not continuous. In that case this will be the L and your this is the spacing. So, if it is continuous, then your L will be equal to S. So, now if it is continuous, then your L will be equal to S. So, I can write that P net will be equal to F into factor of safety. Okay. So, finally, I can write that P net is equal to 1 by 2.67, that is Kp minus Ka gamma H square will be F into the factor of safety. So, from here H expression I will get is equal to 2.67 into F into factor of safety divided by Kp minus Ka gamma. Okay. If it is continuous and He expression is 2.67 into F into S into factor of safety divided by Kp minus Ka gamma L. If not continuous. Okay. So, if it is continuous, S is the spacing, remember that S is the spacing between the anchor rods, L is the length of the anchor rods. Okay. So, if it is continuous, your S equal to L, fine. So, this way I can get the HE, and I will show you in the next class with a problem, example problem, how I will get the HE and how I will place the anchor from the sheet pile. Okay. Thank you.